Hello tech community, welcome to P-TekLearn. In this video series, we will explore Amazon SQS, covering everything from the basics to advanced concepts, along with the hands-on exercises. Before starting the session, please subscribe to our channel if you haven't already. Your support motivates us to create more videos, helping you stay updated with the advanced technology trends through straightforward, simple and enjoyable tutorials. In the previous tutorial of this series, we have seen how to create a queue and test it by sending and receiving a sample message. At the time of creating the queue, we have seen many different configuration parameters along with the types of the queues. In this tutorial, we are going to explore types of SQS queues and also different configuration parameters that we can use to configure a SQS queue. Types of SQS queues. There are two types of SQS queues that we can create and use in our application integration: standard queues and FIFO queues. A standard queue, which is the default queue type, supports a nearly unlimited number of API calls per second and per API action. So meaning each call, that could be send message or receive message or delete message, can have multiple API calls. So it's unlimited. When it comes to the FIFO queues, FIFO stands for first in, first out queues. FIFO queues support up to 3000 messages per second and per API method. That too for batch messaging. If you are sending a bunch of messages as a batch, then it will support 3000 messages per second and per API call. Again, same like a send message batch, receive message or delete message methods support these 3000 messages per second. Here, when we say 3000 messages per second, that means 300 API calls, each with a batch of 10 messages. If we are not using batching and we are just sending an individual message and receiving the individual message, then in that case, FIFO queues support up to 300 API calls per second and per method. Now, if you compare the way messages are delivered, standard queues may deliver duplicate messages. There is no deduplication in the standard queues. Whereas FIFO queues will not allow duplicate messages. So at any point of time, the receiver will get a unique message. And when it comes to the ordering, the message delivery with standard queues will not follow the order, meaning the messages will not be delivered in the order the producer sends the messages. So there is no guarantee for order. Whereas FIFO queues deliver the messages in the order they received from the producer. When the performance requirement is high throughput, then the application has to go with the standard queues. But if the order of the messages, if the order of the events delivered to the consumer is important, then FIFO queues are most suitable. If you remember in our previous tutorial, to create a queue, we have gone through different parameters on this create queue page. So when you log into AWS console and go to SQS service, then you see this create queue page. So when we are creating the queue, first we'll select the type of the queue. So now we know what are the different types of queues and the differences between these two types of the SQS queue. Now let's go through the parameters at the configuration section and see what is the meaning of each parameter. So the first parameter that is in configuration section is visibility timeout. The value for this parameter should be between 0 seconds and 12 hours, and the default value is 30 seconds. The visibility timeout begins when Amazon SQS returns a message for get message method call from a consumer. During this time, the consumer processes and deletes the message. However, if the consumer fails to process and delete the message before the visibility timeout expires, the message becomes visible to other consumers and the message is received again. So that results in duplicate messages. If a message must be received only once, then the consumer application should process and delete the message before the visibility timeout. Message retention period. The message retention period is the amount of time that Amazon SQS retains a message that does not get deleted. SQS automatically deletes messages that have been in a queue for more than the maximum message retention period. So whatever the value we set to this parameter. The default retention period is 4 days and the retention period can be set between 1 minute to 14 days. If the consumers need additional time to process messages, we can set the delay time or the delivery delay each new message coming to the queue. The delivery delay is the amount of time to delay the first delivery of each message added to the queue. Any messages that we send to the queue remain invisible to consumers for the duration of this delay period. The default or the minimum delay for the queue is 0 seconds and the maximum is 15 minutes. Maximum message size. We can set the maximum message size for the queue. The smallest supported message size is 1 byte and the largest is 256 kilobytes. To send the messages larger than 256 KB, we can use the SQS extended client library for Java. This library allows us to send an SQS message that contains a reference to a message payload in Amazon S3. If it exceeds the maximum size, then that message needs to be stored in S3 storage. Receive message wait time. The minimum is 0 and maximum is 20 seconds. The receive message wait time is the maximum amount of time that polling will wait for messages to become available to receive. The minimum value is 0 seconds and the maximum value is 20 seconds. If you remember in our previous tutorial, we saw how to poll the message which is available on the queue for the consumer. So when we click on the poll message button, we saw a progress bar progressing, which indicates that the polling is in progress. Long polling helps reduce the cost of using Amazon SQS by eliminating the number of empty responses when there are no messages available for a receive message request. If a receive request collects the maximum number of messages, it returns immediately. It does not wait for the polling to time out. So here 0 indicates short polling and 20 indicates the long polling. Encryption. SQS provides in-transit encryption by default. To add at-rest encryption to the queue, we need to enable server-side encryption. So if you look at this encryption, by default, it is enabled. So when we enable the server-side encryption, SSE, SQS encrypts all messages that are sent to this queue. The messages are stored in encrypted form and SQS decrypts a message only when it is sent to an authorized consumer. SSE encrypts the body of the message but does not encrypt metadata, timestamp, and other attributes. A message is encrypted only if it is sent after the encryption of a queue is enabled. SQS does not encrypt backlogged messages. Any encrypted message remains encrypted even if the queue encryption is disabled. When SSE enabled, any anonymous send message and receive message request to the encrypted queue will be rejected. And the encryption key type here used is the key that is created by SQS. That is the default one. If you want to use a key which is already stored in KMS, Key Management Server, then we need to enable the second option, which is AWS Key Management Service Key. Otherwise, by default, it selects the SQS key, which is SSE-SQS. Access policy. The access policy defines the accounts, users, and roles that can access this queue and the actions that are allowed on this queue. We can configure basic and advanced settings here. In the basic settings, we can configure who can send messages to the queue and who can receive the messages from the queue. The read-only JSON panel displays the resulting access policy for the queue, as you can see here. By default, only the queue owner can send and receive the messages from the queue. In the advanced settings, we can modify the JSON access policy directly. That allows us to specify a custom set of actions that each principal, like user, role, or account, can perform on this queue. So in this tutorial, we have explored SQS queues, configuration parameters, and types of the queues. In the next tutorial, we are going to talk about dead letter queues, message metadata, list queue pagination, cost allocation tags, temporary queues, accessing event bridge pipes, and managing large messages. So we are going to explore all these different kinds of Amazon SQS features and capabilities. Thank you for watching our video. If you like this video, please like it and then subscribe to our channel. See you in the next video. Bye now.